So let's go to topic 8. So for topic 8 is about Form 4 Chapter 5, hydrogen bond, metallic bond, and dative bond. So for hydrogen bond, it's a bond formed when the hydrogen, right, is bond to those high electronegativity atom, which is nitrogen, oxygen, or fluorine. So technically, if the H got connect to FON, one of the member here, you're able to form hydrogen bond. So what is a effect of hydrogen bond? So the first one would be the normal molecule, they only have van der Waals force. So you just need a little energy to overcome the force of attraction between the molecule, like the covalent bond. So the melting point is very low. So normally it's in gas form. But HF, right, because E has hydrogen bond, because the H got connect to F. So hydrogen bond to F. So there will be a hydrogen bond between the HF molecule. So in this case, right, original you only have van der Waals. Now you have van der Waals plus hydrogen bond. So technically the forces is actually stronger. So now instead of using a little heat, you need a lot of heat to overcome the van der Waals plus to break the hydrogen bond between the hydrogen and fluoride molecule. That's why the melting point will be much more higher than hydrogen chloride gas. Then another effect of hydrogen bond is normally the molecule, right? Covalent molecule, they are not soluble in water, as we have just learned in the topic 7. But if the, like example for ethanol, they have H connect to O. H connect to O. Okay, so they have hydrogen bond. So those molecules that can have hydrogen bond, they're able to dissolve in water. Like example, this is how you mentioned. Ethanol contain H connect to O. So there will be hydrogen bond formed between the two, between the ethanol and the water molecule. So methanol is soluble in water. Ethane, right, you don't have any high electronegativity, don't have FOM. So unable to form hydrogen bond in water, so it cannot soluble in water. As usual, the covalent not soluble in water. Then how the hair will stick together. So the hair has protein end with OH like this. So in this case, right, between the hair they will have hydrogen bond. When you have water, the hair will stick together, become straight, because the water will form hydrogen bond between the two what we call the hair. That it looks like a gel that stick all the hair together. That's why your hair will stick together when wet. Then when you try to turn paper, right, uh, using dry finger is very hard, okay, because paper is using cellulose. Cellulose also got OH, so these also have hydrogen bond. If you lick your finger, means your finger is wet, right? You got water. Water on your finger able to form hydrogen bond with the paper, because got OH here, got OH here. So you're able to stick them so that you turn the paper easier. Then about dative bond. For dative bond, okay, the normal covalent bond will be you take out one to share, I take out one to share. Each of you take out one to share. But for dative bond, right, both actually come from one side. Now, why this happens is because hydrogen ion, it don't have any electron in the shell. For H plus, H will have one, but after donated one, let's say example, H is one, the electron. Okay, one electron. Okay, but if you donated to become H plus, the electron donated out, so it will be an empty shell. So no electron inside the H plus, so it cannot become achieve stable octet-electron arrangement or double electron arrangement. So in this case, right, then you need someone to help. Let's say I call this as a poor, no electron. You need someone rich, which called lone pair electron. So you can see the water here, right? You have these two electrons that not share. This one share with the hydrogen, this one share with the, but these two is an extra pair that can share. So we call it the oxygen atom in water has lone pair of electrons that can share with hydrogen ion. So this will come to here, then they share together. So this is called dative bond. Ammonium was the same thing. Hydrogen also don't have electron. Ammonium, right, they have lone pair here. You can see this is the lone pair. So this hydrogen will move to here and share. Once share, right, this is how it works out. The arrow means the nitrogen borrow money, borrow the electron to the hydrogen. Here is not the normal sharing. You take out one, I take out one, you take out one, I take out one. Okay, so you can write this out. The nitrogen atom in the ammonia has lone pair of electron that can share with hydrogen ion. That's why you take it and share. Then after that, the last one, metallic bond. So for metallic bond, right, you need to understand that for metallic bond, for metal, they are not stable. Example, sodium 2.8.1. So in ionic, right, metal want to donate, non-metal receive. So it works. But for this metallic doesn't work because all is sodium. So everybody want to donate out the electron, but nobody want to receive. So in this case, what happened now? Everybody will just throw away the electron. So ionic is transfer electron. I donate, you receive. Now everybody throw together. We call it that the valence electron of the metal atom can be easily donated and delocalized. Delocalized means everybody will donate out and nobody want. So technically, everybody will become positive charge metal ion, and all the electron will be donated out and nobody wants. Okay, this is called delocalized electron. All the delocalized valence electron can move freely. Just imagine everybody don't want the electron. So it's like a rubbish, everybody throw away. So the floor is full with rubbish. So this electron nobody wants, right? It's like a rubbish that nobody wants, right? They can move freely. And you can see that it actually gather together, become a lot. We call it a sea of electron, like a lot of electron, a sea water. So then this electron, right, and this positive charge, right, they have a positive charge, you see, C of electron is negative charge. Positive charge metal ion Na plus is positive. So they have a electrostatic force between them, but we don't call this as electrostatic. We call it as a metallic bond. Okay, so you need to mention how metallic bond is formed. Then all this electron, right, is able to conduct electric. So ionic compound conduct electric using free moving ion, and then metal they conduct electric using free moving electron. Okay, so you can see that metal has a valence electron that easily delocalized and to form an electron C. All delocalized electron can move freely and carry charge from negative terminal to positive terminal. So you look at a sample question. So here it's mentioned ethanol and propane has almost the same relative mass. So why ethanol has higher melting point? So you mentioned ethanol, it has this. It has H and O. Then my propane, it don't have O. So that's the main difference. Okay, so due to this reason, ethanol has hydrogen bond to O. There will be hydrogen bond between the ethanol molecule. So you need a lot of energy to overcome the van der Waals force between the molecules and also break the hydrogen bond for the ethanol. Then for propane, right, they don't have hydrogen bond. They only have weak van der Waals force, so a very little energy need to overcome them. Then ethanol, why soluble in water? Because it can form hydrogen bond with water. So you can mention also ethanol is soluble in water because it consists hydrogen bond that bond to oxygen. So there's hydrogen bond between the ethanol molecule and water, so it's soluble in water. Then how about the dative bond? So you must mention hydrogen is the poor one that don't have any electron. Then after that, nitrogen, it has lone pair of electron that can share. So they form dative bond. Then using aluminium as an example, explain how metal can conduct electric. So you can mention aluminium has a valence electron that easily delocalized. So after they delocalize, they right, see aluminium is 2.8.3. They have extra electron to delocalize. So after delocalize, right, it become 2.83, yeah. It become positive charge. Okay, positive charge. So all these delocalized electron, right, it can move freely. So if you put a positive terminal and a negative terminal, all these electrons will from negative move towards the positive. So they will move from negative terminal to positive terminal. Then this is the giant covalent bond. You need to know that. For giant covalent bond, right, okay, simple molecule, their melting point is very low. Okay, the melting point is very low. So so the melting point is very low because the van der Waals force is very big. But for giant covalent bond, right, the melting point is very high because they don't have van der Waals force because whole giant covalent, example, diamond, whole diamond is one molecule. So to break the diamond, you have to actually break them one by one, make sure all the carbon is separated. So a lot of covalent bond you need to break. So it will be very, very high melting point. Then you look at the question here. So now you need to decide this. Why this one is higher boiling point, this one low boiling point. So you can see OH here. So you can mention ethanol got H connect to O. So you will have hydrogen bond. Once you have hydrogen bond, you need a lot of energy because you got two force to settle. First is van der Waals, second one is hydrogen bond. Then fine, more ethene don't have hydrogen bond. So the melting point will be lower. Then ethanol can soluble in water. You need to mention it got H connect to O. So you mentioned it got H that bond to O. So it will have hydrogen bond between the ethanol and molecule. Because normal molecule not soluble in water. But if you can form hydrogen bond with water, then you can soluble in water. Okay, then this is a dative bond. They will mention how actually hydrogen will form dative bond with the ammonia. So you must mention hydrogen is very poor, don't have any electron. Then nitrogen in ammonia, this side, they have lone pair of electron. Okay, then the share pair electron, then they take it on share, then this part will be the dative bond. Then what is the substance shows is a metal, so it's a metallic bond. So how you form that valence electron can be easily delocalized, and then you form positive charge ion. For example, let's say if this is sodium, 2.1, they will be easily delocalize their electron out. So after delocalized, it become positive charge metal ion. Then delocalized electron form electron C. So electron C is negative, positive charge is positive. So they have electrostatic force. This electrostatic force called metallic bond. So can it conduct electric? Yes. All the delocalized electron, they can move from negative to positive.